Hello. Now we will study the isochoric process. First we'll go for the explanation. What is the isochoric process? As we already know, in case of gases, there is an ideal gas equation, which is PV is equals to nRT. That is your ideal gas equation. And as you can see in this equation, there are total 4 variables. P is a variable there, V is also a variable, N is a variable, and the T is also a variable. For general gases, the moment we close the gas, the moment we close the system, this N generally that becomes constant. So when we have a gas in a closed system, so the number of moles of the gas in that closed system generally becomes constant. In that case, N also becomes constant. So this ideal gas equation, by putting one constraint, and that constraint is the system constraint. So on putting the system constraint onto this ideal gas equation, now we have 3 variables. So in this equation now we see 3 variables, but we cannot do the calculation for 3 variables. So generally we deal with equation where the variables are 2. So for that we need to define one more equation. So we need to put conditions or constraints onto the process which is happening there. So the very first process we are defining here is the isochoric process. So isochoric process is a process where the volume of the system remains constant, meaning you don't change the boundary of the system. So volume of the system throughout the process, you maintain that constant. Whatever you are changing, you should not be changing the volume. So isochoric process is a process where V is a constant. So this is the equation of, or one of the equation of isochoric process. This is the general equation which always follows. So V is the constant. This is the equation of isochoric process. Okay. Now this equation is always true. So the thing is PV is proportional to T. So in that equation, if the V is constant, you by putting the V here, the constant value of V here, you also get that P is proportional to T. That equation. So either you say V is constant or you say pressure is proportional to temperature. Both of these equations represent the isochoric process. Okay. So these 2 equations, these are the analytical way of representing the isochoric process. Now we want to explain the isochoric process in graphical terms also. So if I plot a graph between pressure of a gas and the volume of the gas, and if I onto this graph, if I want to show isochoric process, so in that case the equation is V is constant. So if you plot the isochoric process onto a PV graph, your graph is coming out to be straight line parallel to the y-axis, which is the pressure axis. So the volume is always remain constant. This will be some V naught. Okay. So pressure will keep changing. Pressure will keep changing, but the volume throughout will remain constant. Okay. So this equation, this graph will represent the isochoric process in PV graph. Now let's go for another one. We want to make the graph, but this time with pressure as a function of temperature. If I want to make the pressure as a function of temperature graph, we'll not be going with this one, we'll be going with P is proportional to T. So P is proportional to T gives you the straight line passing through the origin. You'll have this kind of graph, which if extended will pass through the origin. So this straight line, this graph, this tilted straight line represent the isochoric process in PT graph. Let's go for the third graph, the remaining one. It is between the temperature and the volume. If I plot the isochoric process onto temperature or volume versus temperature, I'll be getting one more straight line, but this time the straight line will be parallel to the temperature, meaning temperature will keep changing without the change in volume. Okay. So these three graphs, all of these 3 graphs represent the isochoric process. There is one thing common in these 3 graphs. If you see in all of these 3 graphs, no line is touching the axis. This is not touching the x-axis. This is not touching. It's not passing through. Actually, it's not passing through the origin. Upon extending, it will supposed to pass through the origin. And here also this will not be touching the volume, because you see this ideal gas equation is not valid for either pressure, volume, or temperature to be 0. So whenever you make a graph in thermodynamics, the graph should not touch x or y axis. If any point onto the graph, the pressure, volume, and temperature should not become 0. Okay, so this is your isochoric process. You can make different types of equations corresponding to the isochoric process. Okay, so we'll do further calculation corresponding to this. Thank you.